get into graphing rational functions. Can somebody remind me what the hell a rational function is? It kind of gives it away in the name. What's the root word rational?
Fraction?
Yeah, it's fractional. So it's like a polynomial divided by another polynomial, right? And obviously, I hope it's obvious, they're going to have slightly freaky graphs. Weird shit can happen. And we sort of got into a little bit of the weird shit that can happen last time. So, just to kind of pick up where we left off. I think. Oh. One thing I did not do for myself. I do. Okay, sweet. Yeah. All right. So last time we started looking at a specific example. Oops. Guess I could turn it on. There we go. So if I have, we've already looked at functions and we talk about domains of the functions. So we already know a function like 1 over x minus 1 is going to have an issue. What if I have the function 1 over x minus 1, can anyone tell me what the domain of that function is?
Negative infinity to negative 1.
Basically everything
Careful.
except 1.
Yeah, everything except 1, right? Because the bottom can't be 0, so the bottom, yeah. So x can't be 1. Okay, let me stop for a minute. Right? Old news. Domain, old news. Now we're talking about what does that imply? What does that mean for the graph of this thing, especially close to 1? It's going to be weird. Weird shit's going to happen. Can somebody tell me? All right, let's do this one at a time. So I think last time I got to the point where I said, if we investigate this, and we start stepping in close to 1, like 1.1, 1.01, we saw that the output kept getting bigger, right? I don't know if you guys remember that.
Yeah.
The last thing I said was, there's another way to get close to 1. This is getting close to 1 from the right. So let me show you a little bit of notation that you're going to see in calculus if you take it, and you're going to see right now if you don't take calculus. I am taking this function, and what I'm doing in this table is I'm looking to see if I let my inputs get really close to 1 from the right. You guys agree with me? 1.1, 1.01, if I look at it on a number line, I'm approaching 1 from this direction. So the formal way, and this is not something you have to do in this class, but I'm just going to show you. The formal way to identify that process, getting really close to 1, is called the limit. So what this means is, what does it look like the function is doing as I let the inputs get really close to 1? The little plus sign means from the right. From above is what I call it, but people think like this, but from the right. So what sign am I going to use if I put in 0.9, 0.99, 0.999?
Negative.
Negative. It's crazy. Holy shit. So again, the idea of a limit, down there, all you, right? The idea of limit is just what does it look like as the function is allowed to have inputs closer and closer to the weird point. So in this case, does it look like there is a limit? Does it look like the outputs have some kind of a place they go? What's your prediction? I'm sorry, I keep pointing there. What's your prediction if I put 1.0001?
It's gonna get even bigger.
Yeah. So what if I put in 1 point, 80 million O's 1?
It's gonna be really big.
It's gonna be stupid big. So what do you think the limit is as I get even closer and stupid close to 1?
Infinity.
Infinity. I love it. So which is another way to say there's no limit. So if the limit equals infinity, That is a way of saying this sucker is just going to grow crazy. Now, I want you to realize what that means visually. Let's do this. Let's be a little specific here. That would be nice, John. So I got my function. Let's just put in a nice concrete number. What's f of 3?
1 over 2.
1 over 2. What's f of 2?
1 over
1 over 1. Right, so it's 1 that's weird, correct?
Mm-hmm.
In fact, will you guys agree with me, whatever the function does, it cannot go through 1.
Yes.
So I'm going to put a wall at 1, because the fact that 1 is not in the domain says you cannot go here. You shall not pass, right?
Mm-hmm.
Okay, I love it. I'm hitting all the geek shit. It's funny, it's a big old wall and they get a little dotted. All right. And sure enough, if I put 1.1 in, the answer is 10. Way the shit up there. If I put 1.01, I am way off. So what's this thing doing? It's like, okay, here we come, here we come. The shield's still operational. Oh shit. And I know some of you guys understand this idea. I'm going to leave this like this for the moment. I know some of you guys understand this idea. In fact, I heard somebody say this earlier. Does anyone know what that's called, that dotted line I drew? Asymptote. You got the asymptotic high five. Ooh. All kinds of dumb jokes. Math is full of dumb jokes. You guys semi with me right now? So all that line says, you could draw it without knowing exactly what's happening there. You just draw it knowing something weird is going to happen there. You are not allowed to be here. In this case, it slams up against it. And again, you could see the concrete reason why, because as I put numbers closer and closer to 1, the output gets really stupid big. Now, I want you guys to take a minute. Do 0.9, 0.99, 0.999. Don't say anything out loud. Try to figure out those. I did half the graph. You guys can do the other. Do 0 and -1 also, just in case. All right, who's got 0.9? What happens when you put a 0.9 in? If you put it in your calculator? -10. So I'll bet you anything this is going to be.
-100. -1,000.
And really, it's for the exact same reason. 1.1 minus 1 is 0.1. 0.9 minus 1 is -0.1. So of course you're going to have the same number at different signs. Does that make sense?
Mm-hmm.
So you got this inherent symmetry going on, but this one now, is it getting really big positive or really big negative? Well, obviously it's getting really big negative. So now it's going to do the exact same thing that side did, just down. Now remember, what's f of 0? What do you get when you plug a 0? -1. What do you get when you plug a -1 in? -1/2. I love it. So at 0, it's -1, and -1 is -1/2. At 0.9, it's -10, so it's doing this kind of thing. Let me zoom out a little bit. Poor little dude. Now, did you guys see that? Do you guys see how I could create multiple? Now, what kind of line is that? Specifically, one that goes up and down. What's the official? Vertical. So this is called a vertical asymptote. Vertical asymptotes are walls that tell me where my function can't go. And why would there be places my function couldn't go? Because they make weird things happen. For example, in this case, it makes the bottom 0. How would I have multiple walls in a problem? Why do I only have one wall here? There's only one thing. So if I had 1 over x minus 1, x minus 3, now there'd be 2 walls, 1 at 1, 1 at 3. And we'd be doing simpler shit. Now the great thing I want you guys to realize, we're not going to do this table forever. In fact, we're going to quickly stop doing the table because we got the idea now, I think. When I've got this asymptote, what's going to happen very often, not every time, oh shit, but very often it's going to slam up against it either like this, it could do like this, or it could do like this. You guys kind of with me? Infinite volcano, yes.
Would there be a horizontal asymptote?
Hell yeah. We're not there yet. But yes, there will be a horizontal asymptote. I love it. That would be like if there was some kind of a ceiling or something. Yeah, we'll see. Okay. Now, I haven't filled this stuff in yet. Like, what's it do from here? Can anyone tell me very quickly if this guy has any x-intercepts? What would have to be true for it to have an x-intercept? How do you find the x-intercept of something? Am I even pointing the right way? Say again?
Is that y 0?
Yeah, good. And where's y? What symbol up there, of course, means y?
Oh, f of x.
Yeah. So if you make that 0, now tell me real quick. If you make f of x 0, that's telling me I got to figure out when is 1 divided by a number equal to 0. Can you ever take 1 divided by a number and make it 0? What's the only way a fraction can be 0?
If the denominator is 0.
No, that's undefined. That's infinite, actually.
Oh, if the numerator.
If the top is 0, right? The only way you can make a fraction equal 0 is if the top is 0. Do you guys not just agree with me? Gosh. You guys not just agree with me, but understand that. Okay, I like it. This top's 1. So are there any x-intercepts?
No.
No. So there's something weird happening at the freaking x-axis too. There's something weird this way and there's something weird that way. So if I make x really big, do you see how that answers the question about what the shit is it doing? In fact, this is kind of like end behavior. When I make x big, what is this stupid thing doing, right? Well, let's check it out. How do I check that out? What do I do to check out what happens when x gets really big? Can I do something similar to something we've already done? So this would be limit as x goes to infinity. This really just means what the hell happens if I let x get really big. That's how to read that in English. Well, couldn't I just make a table? And we'll put in there like 100, 1,000. Can somebody help me out? What is 1 divided by 100 minus 1 divided by 99?
0.0101.
Yeah! Alright, Jeff, calm down. Yeah, 0.0101. What's 1 divided by 999?
0.001001. Repeat 9.
And of course, if I put in 10,000,
0.0001.
yeah, I'll bet you anything, right? So what's happening as I put larger and larger inputs? What's happening to the outputs? They are getting smaller and smaller in a very prescribed manner. So I feel very comfortable predicting what's going to happen. If I make x stupid big, my output's going to be really, really stupid close to what?
0.
0. Does it ever get to 0 is
No.
the key. Because do you notice, I want you guys all to notice, do you see how every time I do this, this 1 gets pushed out one more place?
Mhm.
That 1's always there though, isn't it? The only way you could equal 0 is if all of these were 0, correct? But aren't you always going to have that 1 somewhere way up there? Even if you put in a billion to the billion to the trillion to the trillion to the billion to the million to the trillion power, there's going to be 1 way out there, right? You guys kind of follow? So it's never going to equal 0. We already knew this dumb fraction couldn't, nothing against your fraction. We already knew it couldn't equal 0 because the top's 1. But this is just verifying, yeah, you can never get to 0. So what's happening at the x-axis? I can get close but never get there. It's like this guy. So there's an asymptote here. So that's answering the earlier question. Can we get horizontal asymptotes? Yes. So where do vertical asymptotes come from? Where did that vertical asymptote come from? Domain. Kick ass. I love it. Cheers. That's exactly what I want to hear. Vertical asymptote comes from what's not in the domain. I've got to put a wall there. That kind of makes sense. I just put a wall there. You can't go here. Where do horizontal asymptotes come from?
Range.
Also with range, I guess.
Sort of, but it's what happens when my inputs get really big. I want to be more specific. Because in the middle, that's also the range too. But, so what happens when x gets really big? It's related to n behavior. Right? So if he ends, this sucker looks like 0 almost. But in the middle, it can do weird shit. Yes?
But it doesn't necessarily mean it's like whenever there's no x-intercepts, right? Because there can be like a horizontal asymptote like at 1.
Of course, totally. Of course. This is just our first example. So could the horizontal asymptote, another good question would be, could that horizontal asymptote be somewhere else? Of course. Definitely. How would that happen? We don't know yet. We're going to figure it out.
Equation.
Huh?
Different equation.
Different equation. Yeah, that makes sense. How are we doing so far?
Oh,
No? Yes?
You do like a transformation, and then like everything moves up.
You could look at a lot of what we're doing as transformations. I'm not going to, because if we look at it in terms of placement of things. So for example, the most basic, I almost killed myself there, the most basic hyperbola. Do you guys agree this is, I don't know if you guys understand. You guys know hyperbolas? We're going to talk about them later, but basically, a hyperbola is something kind of like turns its back on itself. Like one half doesn't want to talk to the other half. Yeah. Right? And we have, for example, if I put Earth here, we have comets that have hyperbolic orbits, so we only see them once ever. Because they come in, like, oh, look at that cool, and then it goes forever away. Good to see you. And of course we have Halley's Comet, for example, that's on a giant elliptical orbit, comes by every 76 years. You guys know that? I can't remember the last time it came down. Shoot. Oh, who else is gone? Too bad. Okay. Yeah. So I could look at, really quickly, don't even write this down necessarily, but if I had 1 over x, what's the not allowed input?
0.
0. So it would just be this graph, not shifted right 1. See how this has been shifted right 1? So it'd just be the exact same graph, just not shifted right 1. We're not going to look at these as transformations because it makes it so much worse, especially when I have multiple things happening on the bottom. How the hell would transformations happen then? Okay. So now we know vertical asymptotes come from the domain, what's not allowed. We put a wall there. Horizontal asymptotes come from what happens when x gets really big. You guys kind of with me? Could I cross through a vertical asymptote?
No,
No. Could I cross through a horizontal asymptote?
yes.
Oh yeah, I could cross through a horizontal asymptote an infinite number of times. It's good for you, Jeff. Real quick, what happens when I pluck a guitar string? What thankfully, what happens over time?
Vibrates,
It vibrates, but what happens over time? Just let it sit there.
fades.
It fades, thank the gods. If it didn't, every guitar that's ever been strummed would still be going. Sorry.
Some guitars have awesome sustain.
Say what?
Some guitars have awesome sustain.
Yeah, oh yeah, there you go, exactly. So sure, you can talk about and what's really cool is the math behind constructing a guitar that has different properties. But we're not gonna go into guitar making math, I'm sorry. That'd be a whole different class, we don't even know. So I could have, for example, just to give a little preview of where we're headed eventually, I could have, do you guys know what this is called?
Sine wave.
Sine wave, okay. You all have seen sine waves before. If you ever watch any horror movies, there's very often an oscilloscope in the back with this going. Or if anybody does any work with music, very often you'll look at the oscilloscope, the frequency, and you kind of adjust it. If you go too far, it cuts off at the top and so forth. Anyway, if you've never done that, you're fine. But I could have a horizontal asymptote, and I could pluck this guitar string, and over time, it's going to approach this. That's all a horizontal asymptote means. It means over time, your function must get closer to me. That's all a horizontal asymptote means. Vertical asymptote means you cannot exist here, right? Horizontal asymptote says, over time, just get close. Get close to me. You can play over there, but come close to me. You guys kind of with me? This is an extreme example. Most of the ones we're going to look at are going to look something more like this. I'm going to have a horizontal asymptote somewhere, and then it's going to come in like, yeah. And then it could have a vertical asymptote here, and then it could be like, I need you to understand, the walls we set up tell me where my function could possibly exist. And then the intercepts and other points we find tell me where the shit they are. So that's where we're headed in a bit. So the walls are what we normally draw first, because then I can kind of live within them. I just got to plug a few points in to see where the hell I am once I've established where I'm allowed to be. I don't know if you guys are really with me. We're getting there. Okay. How's everybody feeling? You guys good? Okay. Anybody jet lagged? There's a bill right now to stop daylight savings time, so we'll see. Well, California maybe. All right. Okay. So let's look at one that's a little more complicated. Sure.
So what results in an oblique asymptote?
We'll get there. We're so not there. We are so desperately not there yet. All right, guys, can you, without saying anything, can you take a minute and figure out the two vertical asymptotes? Don't say anything. Oh, thank the gods. I brought one. Oh, sorry. You just skied there before. That's funny. Wintergreen. Used to live in Virginia. I see people just staring at me. Have you already done it? Yes.
You said you used to live in Virginia?
Yes. I lived in Norfolk, Virginia. I always loved listening to reporters try to say Norfolk. Norfolk? Oh, it's Norfolk, Virginia. I lived in Norfolk. I lived in Chesapeake for a while. I used to work at Virginia Wesleyan College. All right, guys. What do I have to do to figure out the two vertical asymptotes?
Factor at the bottom.
Factor the bottom, 11. So I'll assume you guys know how to do that. So what are my vertical asymptotes?
Positive 3.
X equals positive 3, x equals in positive 3 and negative 3. So I've got two walls, correct? Then my question is, where's the horizontal asymptote, or is there a horizontal asymptote? So I want you to realize something. That first problem we did, the reason it really makes sense that 0 is an asymptote is because when I make x really big, does the top change at all? In that problem we did a minute ago, does the top change? Top is always
1.
So the bottom is getting stupid big, and the top is just 1. So if I divide something by something that's getting bigger and bigger and bigger, my outputs get smaller, 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 of course, right? Is that happening in the one we're looking at right now? As the bottom grows, what does the top do? As x gets really big, the bottom grows, like x squared. Is the top staying the same? As x gets big, how does the top change? Huh?
It's growing stupid fast.
As stupid fast as the bottom is, correct? They're staying lockstep with each other. Does that make sense what I'm saying? So the first one had no chance. 1 divided by 100 is already stupid small, and then the bottom is just going to get even bigger and bigger and bigger, so the whole thing is going to get to 0. Here, they're going lockstep with each other. So we're going to make a table. It's the last time we're going to make a table for this kind of thing. So I want to put in there things that are close, and not close, things that are big. So be careful when you put this in your calculator. Do it like this. Can somebody please plug a 10 in and tell me what you get for an output?
Um, 1.099.
Sounds all right. Now somebody else tell me what you get for 100. And when you put in the calculator, be very careful. Tell it what the bottom is. Poor little calculator's got no eyeballs. So you would do 100 squared divided by parentheses 100 squared minus 9. If you put that in your calculator, you should be good. Who's got that?
1.00090081.
Blah, blah, blah. And of course, you can see what's happening here, correct? So if you put 1,000 in, does anyone have that for me? I'm curious what your calculator does. Just in case anybody's having trouble, put this in your calculator. I'll do 1,000. Oh, neat. Okay. 1,000 squared divided by 1,000 squared minus 9. 1.000009, blah, blah, blah. Here's a cool little trick, you ready? Anybody wants to play along with me, let's do it. 1 with 1, 2, 3, 4, 5, 6, 7, 8 zeros, right? Watch this, this is so cool, you ready? I'm gonna store that, see the little store button? I'm gonna store that in X, my little X button. Then I can just type in here, x squared divided by x squared minus 9. And this is gonna come out to be 1. Yeah. Now, it's not really 1, to be honest. I need you to understand this. The calculator, is it able to show when it had like 0.7800 zeros and then a 1? Is it able to show that?
No.
At some point, or in this case, 1.78 zeros and then a 1. It's just going to give up and go, it's freaking 1. You guys kind of see, but it cannot be 1. I could never get there. What's the only way this ratio could be exactly 1?
If it was exactly the same numerator
Yeah.
and,
Is the top ever exactly the same number as the bottom?
no,
No. But does it make sense that over time they're sort of getting closer? I know in one sense it doesn't make any sense. But if I put a, what in there, Jeff? A 4 in there, that's 16 over negative 5. If I put a 10 in there, we already got that's 1.0. If I put larger and larger numbers in, this ratio is getting closer and closer to what? What's the biggest degree term in each top and bottom?
second,
So if I put 18 trillion in here, how important is this? If I won a lottery and got $18 trillion, which by the way, no lottery does, but let's just pretend. And they're like, oh, we're sorry, we have a $9 service fee. Is that gonna bother me? No. What if I won a lottery and I got $10 and they're like, oh, sorry, you've got a $9 service fee. Would that bother me?
Yeah.
Yeah, so when this is small, this means something. When this is big, this don't mean shit. And what do I get when it's big then? I basically get 1. That's sort of a less technical way to see that this is going to be 1 in the long run. So where is my horizontal asymptote? Be specific. My vertical asymptotes are x equal 3, x equal negative 3. What did we just figure out? The outputs get really, really close to 1. So how do I say that? It's 1, right? What's 1? Vertical, x equals. Horizontal,
right,
y. Yeah, horizontal lines are y equals. Let me stop for a minute. Oh, you guys like this, I can tell. Okay. What's the, let's do this. What's the x-intercept for this problem? I'm sorry, I keep pointing, there's monitors everywhere, I'm sorry. They all show the exact same thing, so no matter where you point, you can look at whatever you're looking at. What's the x-intercept for this problem?
-9? Or wait, no.
What do you get on the top when you make, I'm sorry, how do you make y 0?
0 equals x squared.
I put a 0 in, right? Put a 0 in, don't I get 0? So of course the y-intercept is also 0, 0. That's the one point that's both an x and a y-intercept. Let me stop for a minute, you guys kind of with me? No? So again, how do I find a y-intercept? I make x
Zero.
0. 0 over negative 9. 0.
Zero.
How do I find the x-intercept? I make y 0. So when is this fraction equal to 0? When the top is 0. When's the top 0? When x is? When is the
Zero.
top 0? When x is 0. Right? How do you make x squared 0? You just make x 0. Right? How we doing? You got this right? So there we go. So let's try to graph what we know so far. There's an intercept at 0, 0. There is a vertical asymptote at 3 and negative 3. You guys with me? In fact, you guys told me that, so. Right? There's a horizontal asymptote at 1. Y equals 1. Let me, do you guys see how I cut this into 3 regions? Let me really make sure you guys look at this correctly. Do you guys see the 3 regions? I'm going to draw, this is one nice thing about having this projecting screen that I can write on. One thing that could happen is, it could look like, in the middle it could look like this, it could look like this, it could look like this. You guys am I with me? Because, is x really big in the middle? In the middle, is x big?
No.
1, 2, no, in the middle x is small, so I can go through this stupid, I can just ignore that, because when does that wall come into play? When x gets really big. Okay. So it could do any of those things. You guys, over here, it could either be up here or down there. Over here, it could either be up here or down there. Now, real quick, if somebody turned this in as an answer, why is it immediately obvious this is not the answer? Is this a function? Did I give you a function as a problem? Is this a function? Is this a function? Is this a function? Yes. Yes, it is a function. Right, for every input, I only get one output, by definition. You guys with me? Is what I've drawn there, is that a function?
No.
No, okay, good. So my point here is, it could either be here or there in this first region. It could either be here, there in this second region, and it could either be up there or down there in this third region. You guys with me so far? And again, we're just learning right now. Okay. What's the only way that it could exist here, for example? What would I need to be able to have? What would have to exist right there? What would this be if that was here? That would be the x-intercept. Do I have an x-intercept up here? Where's the only x-intercept I have?
At 0, 0.
Here. So can it be here? I need you to see that. What's the only way I can get through the x-axis is if somebody put a door there. What do I mean by door? I mean x-intercept. That's how I get through the x-axis. Is there a door over here? No. So I know it's going to look like that. To be really sure, what function input can I check? Yeah, what's f of 4? What's f of 4? 4 squared over 4 squared minus 9. 16 divided by 7 is roughly 2 point something. 2 point. You can do it, Jeff? No, you can't. What is it? About 2. Okay, so if I go up here, at 4, it's roughly 2. So yeah, that's confirmation it lives up there. And then it's got to go up against that wall, and it's got to go up against that wall. I need you to see how the walls kick so much ass. The minute you know where a point is, the walls kind of guide you as to how to draw it. Let me stop for a minute. So is everybody cool with the fact that there are 3 regions, because there are 2 vertical asymptotes? So that region could have been down here. There's no x-intercept, so it must be up there. What about here?
Same thing.
Same thing. So I know it's going to be up there. I could plug in -4 to figure it out, but I already know it's up there. What about in the middle? How the shit do I... There's a million different things it could be. Damn it. So, of course, what am I going to do to check it out? Yeah, I can plug in 1. I can see where is it at 1. At 1 is going to be x squared over x squared minus 9. So it's going to be negative 1/8. So it's down here. What about negative 1? So negative 1 over negative 1 minus 9. I'm sorry, x squared. Negative 1 squared over negative 1 squared minus 9 is going to be symmetric. You see that? It's negative 1/8. Are you guys with me?
Yeah.
So therefore, it must look like this. Yeah. So it all day could have gone up. It just didn't. How did I determine where it went? I put a couple of points in. Doesn't that feel like what we did with the earlier graphing? When I knew the x-intercepts, I put a point in the middle just to see how high or how low it went. Same idea. Pretty much the exact same idea. Stop for a minute.
Except instead of a door there, it's more like a vertex.
Sure, the middle looks parabolic, but it's not. Parabolas have specific curvature, and this won't have the same curvature, but it looks like a parabola, right? Yeah. I mean, let me see. How are you guys feeling right now? There's a lot coming at you. So let me do one more discussion about horizontal asymptotes, and then I've got my little handout I'm going to give you. All right, that immediately needs to kind of. Has everybody got that? Yes.
How do you get y equals 1?
Oh, up there. Oh, by this work here. When I put larger and larger values of x in, I got numbers getting close to 1. Yeah.
And then you
We're gonna improve, we're gonna make a shortcut so I don't have to make the table all the time. Okay. So I want you to notice when my function was, let me erase this stuff. When my function was 1 over x minus 1, what was the horizontal asymptote? The very first problem we did. 1 over x minus 1. What was the horizontal asymptote? What was the horizontal asymptote?
1.
0. When we did the one just now, that was x squared over x squared minus 9. Horizontal asymptote was 1. What's true here about the top and the bottom? Which one has a bigger degree? On the first problem, which one has a larger degree, the top or the bottom?
The bottom,
In fact, what is the degree of the bottom?
1.
Why is the degree of the bottom 1? Because I see a single x, x to the first power. So what's the degree of the top?
0.
0. I don't see any freaking variables. So isn't the degree of the bottom bigger? In general, stay with me now. In general, if the degree of the bottom is bigger than the bottom is going to grow faster than the top. Does that make sense what I just said? If it was x over x squared plus 1, the top is going to grow 1, 2, 3, 4, 5. The bottom is going to grow 1, 4, 9, 16. It's going to grow faster. So I still have a situation where I'm dividing something by a number that's getting bigger quicker. That whole thing goes to 0 then. When I divide by a bigger number, I go to 0. I get smaller, correct? G of x. When the horizontal was 1, what's true about the degrees? Of the top and the bottom.
Say again?
The degree of the top and the degree of the bottom. What's the degree of the top in G of x? What's the degree of the top? Second degree. What about the bottom? Second degree. So they are growing equally quickly.
Yeah.
It makes sense they sort of cancel each other out. Neither one of them wins, right? So the shortcut to figuring out the horizontal asymptote is just what's the highest degree, what's the ratio of the coefficients. If I would have put a 2 here, the top would have been always twice as big as the bottom, but they would have grown at the same rate. It would divide to be about 2. Maybe. So for example, if I have this, what you got, Jeff? What's the degree of the top? This X is just, I don't know why he's down there. What's the degree of the top? Third degree. What's the degree of the bottom? Third degree. Same degree, they're gonna go lockstep. What's the coefficient of the largest degree on the top?
2,
And what's the coefficient of the largest degree on the bottom?
6.
No,
Oh, 5 minus 6.
no,
Oh, it's -1.
-6.
Oh,
Right,
Oh,
the number
oh,
in front of the x cubed is -6, correct?
got it.
So the horizontal asymptote will just be the leading coefficient on the top divided by the leading coefficient on the bottom. What's the only time that happens? When the degrees are the same. So if I were to go to graph this at -1/3, there would be a wall, a horizontal asymptote, I should say. We won't graph that one because that one's a little bit gross. Okay. So there's only one situation we haven't covered yet. So we got when the bottom degree is bigger, we got when the 2 degrees are the same. What's the only situation we haven't covered yet? We got the bottom degree is bigger, or the 2 degrees are the same. What's the third one? The top's bigger. I love it. So if I have a problem like k of x equals 4x squared minus 7x plus 3 over x plus 2, top degree is higher, right?
Yeah.
So when I plug bigger and bigger values of x in, the bottom cannot keep up with the top. You guys kind of with me? So it's like doing 10 divided by 1, 100 divided by 2, 1,000 divided by 3. Isn't the answer just getting bigger and bigger? The bottom cannot keep up. So in this case, will there be a ceiling or a floor? Will there be... No, it's going to go to infinity, right? Now this is where we get a weird little dude. We're going to talk about it not quite right now. So we're going to say there won't be any horizontal asymptote. There will be a type of asymptote that we'll talk about. I'll go ahead and give it a name. I think I gave it a name on the... So the book sometimes calls it oblique. I like to call it a slant asymptote. We're not going to do an example of that quite yet. I want us to get the basics down. So let me give you this handout. Any- So, I used a little bit of technical language, but I tried to capture what we just talked about. In this example function I gave, what's the degree of the top? Well, I tell you, but it's the nth degree. So I've kind of written this in descending order. Degree of the bottom is m. You guys all with me? I got to cover all my bases, so I got to use freaking variables. If the bottom degree is bigger than the top, the bottom dominates. So the bottom gets bigger faster. I'm going to divide by bigger, 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 so I'm going to go to 0. There's going to be an asymptote on the x-axis. A horizontal asymptote. You guys with me? If the degrees are the same, then it's just the ratio of the leading coefficients. You've got to be careful. That doesn't mean the first numbers. It means the numbers in front of my biggest degree term that might be out of order. Right? And then this one we'll talk about in a bit. I call it a slant, but the book might call it oblique. So we're not going to talk about this quite yet, but just to make a complete picture, I'll say there it is. So which situation am I in on this one? They're both the same. So can anybody just eyeball what the asymptote's going to be?
3.
Yeah. So the horizontal asymptote's going to be 3, same degree, top and bottom. I'm going to do this once. I'm going to show you a slightly more technical way. Reason that this asymptote is 3. So if I'm looking at what happens when x gets really big, so again, this whole notation, it's not something you're going to be, you're not going to need to be able to fully understand it to do any work in here. I'm just trying to kind of give you a little preview of calculus. One of the very first things you talk about in calculus is limits. So all this symbol means is if I take this expression and let the inputs get really big, that's all this means. Is there a limit? Is there a ceiling or not? So one way to look at this, let me ask you this. If I'm letting x get really, really big, I'm letting x get really big, correct? Could x be 0? If I'm only looking at when x is really big, could x be 0? No, because that's not big. I'm only considering x to be a trillion, a billion to the billionth power. You guys semi with me? So then I could do this. I can divide top and bottom by x squared. So then I get this. You guys see that? If I divide by x squared, they cancel here and here. This is just there. 1x cancels here, and then this gets divided by both x's. What happens to this when x gets really big? 3 divided by big ass number. What's it going to go to?
It's gonna get small.
It's going to get really small. It's going to go to 0. What about this? Same thing, right? What about this? Same thing. Does 3 give a shit what x is doing? No, it's just 3, right? So what's the answer then? If these all go to 0, don't I just get 3? That is the more technical reason why the horizontal asymptote is 3 in this case. I'm not going to make you do this, but in calculus, you might actually do some of this, just to show you. Okay. So coming back to this guy. Y equals 3 is my horizontal asymptote. What are the vertical asymptotes? How am I going? What's a really good first step? Anytime they give you a problem like this, factor everything, right? How do you factor the top?
3x plus 3.
No. What comes out?
It'd be 3 comes out, and it'd be x squared minus 1.
Is that cool?
Yeah.
What about on the bottom?
X plus 3 and x minus 2.
Yeah, x plus 3, x minus 2. So let me just blah, 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 blah. X plus 3, Jeff. That's horrible. Let me write this again. What's up?
Will the vertical asymptote be negative 3 and positive 2?
Yes, so the vertical asymptotes. Now that we factor the bottom, I can see exactly what x values I'm not allowed to use. I'm not allowed to use negative 3 and 2. If the question was, what's the domain, you would say x not equal to these. But the question is, where are the walls going to be at x equal to this and x equal to that? Now, real quick, up here, could somebody tell me the x-intercepts remarkably quickly?
3.
No, careful. No? What makes this 0?
Negative 1.
Negative 1.
And what happened? And 1.
1. So again, x-intercepts come from letting the function output be 0. It's the only way a fraction can be 0. If the top is 0. So when I look at the top, I've already factored the damn thing. I could just see exactly what makes it 0. Negative 1 and 1, yes? You guys with me? That's why the very first thing you do with this, if it's not already factored, is you factor the damn thing, everything. Now real quick, is 2 an x-intercept? 2, 0. Is 2, 0 an x-intercept? Definitely not, right? It's a vertical asymptote, correct? Well, it's the only way this fraction could be 0 is if the top is 0. So I sometimes get people just give me a ton of intercept. No. It's only from the top. It's the only piece of this. The bottom being 0 makes the whole thing go insane, right? So that can't possibly be an intercept because it's gone crazy. What's the y-intercept? Much easier to see here. If you make x 0, what's left?
-3,
Over.
-6.
For where we're going.
1/2.
Yeah. Is that right? You guys with me? That never changes. That shit, I don't care. I think I told you, didn't I tell you guys like the last course I took, an equation that had like 27 variables. So how did I find the w-intercept? I made all this other stupid letter 0. So I don't care how high you get up in math, how many axes, how many dimensions you live in, how do you find a single intercept, make all the other letters 0? It's crazy. That idea carries. That's just the way you do it. Okay, let me stop for a minute. We got our intercepts. We got our vertical asymptotes. We got our horizontal asymptotes. Here I'm being nice to you. Somebody help me out. What is f of -4?
450.
What do you get?
450.
450?
Yeah.
Let's see real quick. Oops. F of -4. So it'll be 3, -3, -5 over -1, -6. I don't think it's going to be. Yeah. So I'm getting 45 over 6, which is roughly something, 7.5.
Would you have to square?
Huh? All right, so real quick, how did I do this? I always find it's easier to use this form. If I make x -4, it's just a much nicer. Now here you could totally do it here. That's fine. But you should get the same thing. In fact, let's put it in there too. So I would get 3 times -4 squared minus 3 over -4 squared plus -4 minus 6. I get 48 minus 3 is 45. 16 minus 10 is 6. 45 over 6, you get the same thing. Yes? Okay, let me stop for a minute. Of course, you guys have calculators, so I don't mind you plugging stuff in to get points for that you got a graph. That's fine. This is not me checking to make sure you know how to subtract and divide class, right? Okay. F of, sorry, good.
An F of 9.
You got it? Okay. What's f of 3? So that would be 3 times 4 times 2 over 5 times 1. So I get 24 over 5, which is 4.8. I think I told you the quick way to divide by 5 is double the top and then move the decimal back 1. Because if you double the top bottom, you divide it by 10. Blah, 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 blah. Or I know, you got these things. Great. Okay. So, take a minute. Real quick. We know some more outputs now, correct? So what seems to be a decent scale to use on the y-axis, maybe? Yeah, sorry.
Well, what's the bottom number?
What's the bottom number? What do you mean?
24
Sorry.
divided by what?
Huh? What?
That's not
5.
right. 24 divided by what? 6. It's supposed to be. Yeah, I got
6. Okay, 6.
I got 4.
So you got 4. Gotcha. Thank you. So what kind of scale should I make on the y-axis? And again, guys, thank you so much. We will help each other out when we make mistakes. I'm open to it. I'm a human. I'll make mistakes.
By 2.
Yeah, I want the y-axis to be able to go to 7.5. It's got to include that. So I'm definitely not going to do it by 1s. 2 seems to be perfectly fine. You don't want to make a scale bigger than you really need because then everything gets smushed. So I'm going to make my y-axis scale by 2s. And my x-axis scale, everything that needs to be on my x-axis seems to be live within 5. So I can just keep it as my 1s. Right? So it'll be 2, 4, 6, 8, 10. Yeah, who knows? And then 1, 2, 3, 4, 5. So let me stop for just a minute. This is the step that some of you guys sort of skip a little bit. Notice how my y-axis can have a completely different scale than my x. We should know that. But the top part of the y-axis has to have the same scale as the bottom. You can't suddenly change how big each step is, or else your graph gets all really freaky. So your first thing you're trying to figure out, the first thing you're going to plot is actually your scale, because then you know where to put the stuff. Now, what else can I plot with it before I draw anything? What can I plot?
Your x-intercepts.
X-intercepts, kick-ass. That's the next thing I normally do. This is my anchor points. X-intercepts, -1, 0, and 1, 0.
The vertical and horizontal.
Yeah, I could put my walls in. So there's a wall at -3. There's a wall at 2. And then what's my horizontal one? 3, right? Is that cool? So I'm going to put a wall at 3. Gotta go right down the middle. Cool.
Wait, where?
Sorry?
Aren't they supposed to be -1 and 1?
Say again? Sorry?
Sorry, never mind.
Okay. Are we all good? Okay. Alright. So again, I've got 3 regions. It won't always be 3.
I would plug in 0.
Where's my y-intercept?
I would plug in 0.
Plug what, sorry?
I would plug in 0.
We already did. What's my y-intercept?
You did? Oh,
Right, so
1/2.
0,
1/2.
3.
Right, my y-intercept 0, 1/2, correct? Okay. Now be careful, this is 1, so 1/2 is way over there. Now listen, I'm going to throw one more thing at you. And this kind of sucks a little bit. This is not always going to happen. Do you see all my x-intercepts and so forth are in one region? That actually is kind of nice, to be honest, because I already know what the extreme regions look like. Could I possibly have this one here? You see, again, the walls tell me what the shape could be. It could either slam up against this one and slam up against that one. Why can't it be like this? Why wouldn't this work? There's no way to get through the x-axis here. There's no x-intercept. So I know already it's going to be up here, right? I just got to put a point in if I want to be more precise. You guys with me? So it seems like there's no information out here, but actually no information means you have information. It can't possibly be here because there's no x-intercept. So I know it's going to be up there. Same thing over here. And here, now here's something. Please, there's no reason to plug more shit in. You ready? This is an idea. You guys are just like, really? It still works? Multiplicity. What's the multiplicity of each of my x-intercepts? They're each 1. Is it going to go through or turn?
Through.
Odd multiplicity. It's going to go through. So I already know the middle is going to look like this. Through, through. It's kind of unfortunate the last 2 we did look the same. They don't have to look the same. If I want to be a little more precise, what can I plug in to see exactly where it is here?
-4.
Yeah, -4.
We already plugged the -4.
No, we didn't.
No, we did.
Oh, yeah, we did. Oh, yeah, I did. Thank you. So on the back, and in general, I'm not going to be so nice. I forgot that I was nice. So I already know -4 gives me 7.5. So -4 is 7.5. And I know it's got to slam up against that wall, and it's got to slam up against that wall. And f of 3. And I can see why in this problem where I'm being really nice, I told you what to plug in. For 3, we got 4 with your help. So it's there. So this is going to slam up against that wall, slam up against that wall. Guys, at all with me? All right, let's do this. This is the step that some of you guys do first, and that's your downfall. Don't ever do this first. Now, some of you guys are going to do it anyway, but oh well, I try. 3x squared minus 3. Yeah, divided by x squared plus x minus 6. And we're going to do this, always do this, zoom 6 to get a standard window. What do you guys think? Yeah. Now I could do this. If I make x min -5 and x max 5, it's gonna perfectly match up with mine. So I got a little snippet. I got this big old boy here, and then I got this little dude. I like it. See how he's quite not symmetric? Do you guys see that?
Yeah.
I don't want to see that shit. I don't want to see anything specific that you could only know after you had the calculator do it for you. I never want to see that. Because otherwise I'm going to ask you, oh, did you figure out the slope and the curvature and all that? Show me the work.
Couldn't you tell that it's not equal because of where the middle is compared to the asymptotes?
Oh, totally. Yeah, totally. There's reasons you could tell that it's not symmetric. But when you go to graph it, I would expect most of us to make that basically look like parabola.
Okay.
Does that make sense? Again, when I see too many, and in fact, I still have people, you gotta believe me, if you ever turn in an answer for a graph and it looks like this, you guys understand? You guys understand what I'm saying?
Yeah.
It looks like that you graphed the damn thing. You just didn't make your Y max big enough. My God, put a little more work into it if you're gonna cheat, right? Okay. All right. So I want you guys to do this one. Oh, wait. Boop. So the top factor is easy enough. Oh, there'd be paper. Okay. And the bottom, you take an x out, and then you realize it's going to be +4 minus 2, right?
Mm-hmm.
So the x-intercept comes from the top. The y-intercept comes from making this 0, but making x 0, but of course that's undefined. So you can either say undefined, or does not exist, or whatever. Or none. I love it. Vertical asymptotes, there's 3 of them. There's x equals 0, like we just said. There's x equal 2.
X equals -4.
-4. What situation am I in? And it's always easier to see that here. Yeah, the top, bottom degree is higher than the top. The bottom's growing faster. The whole thing's going to get small. It's going to go to 0. So both of my axes are asymptotes. Neato. Stop for a minute.
So it's y equals 0 because the top is smaller than
Yeah.
the bottom?
Top degree less than the bottom. So I need this to make sense. If the bottom degree is bigger, the bottom is growing faster. If the bottom is growing faster, I'm dividing by bigger, bigger, bigger. So I'm going to go smaller, smaller, smaller. I'm going to go towards 0.
So since there's a horizontal, I mean, since it's 0, does that mean there's no x-intercept either? How does that work?
No, no, careful, careful. Which asymptote can I never go through? Vertical asymptote. Horizontal asymptote, I can go through it an infinite number of times. What's the horizontal asymptote say? The bigger x gets, the closer you should get to me. That's all it says. You guys kind of with me? So when x is 0, 2, -4, is x big? Is x big at 0, 2, and -4? No. So that's fine that it goes through the horizontal asymptote. That's fine. The vertical one is the, you cannot go here. The horizontal one is, hey, can you get close to me when, x gets big? Yeah. Say again? How do you find the y-intercept? What happens when you make x 0 on the bottom? And what do you get when you divide by 0?
Shouldn't it be 0 and 0?
So you make x 0, you get 4 on the top. Is that cool? 4 over 0. Yes? You can't do that. There is no number that when you multiply by 0, you get 4. So that's why one acceptable answer is undefined. You could also say it doesn't exist. You could just say no, none. You could say no y-intercepts. Is you guys with me? Okay, cool. And again, we see another reason why in this case. That's a vertical asymptote. I'm not allowed to exist there. So of course there's no y-intercepts. Okay. Now, I'm not gonna pick my Y scale yet, but I can plot stuff on my x-axis. What scale do I want on my x-axis?
5 or 1 on.
I can go by 1, go up to 5. I love it. I know. So 1, 2, 3, 4, 5. Okay, so I got 0. I got 2. I got -4. That's my vertical axis. I got 0. I got 2. I got -4. Arg. Where are my? Start over. Damn it. Where are my my x-intercepts? There's only one, right?
Well, -2, 0.
So -4, there's a vertical asymptote. 0, there's a vertical asymptote. 2, there's a vertical asymptote. -2 is my x-intercepts, right? -2, 0. So I have like no information. What is the multiplicity of -2?
1, 2.
Yeah, 2 right there. It's right there, right? Where did -2 come from? A squared term, so it's got a multiplicity of 2. What's it going to do there? It's going to go through a term. It's going to turn or bounce, whatever you want to call it, right? Bounce. Alright. So how do I figure out my
Plug in -3.
y-axis scale?
Plug in -3 and -1.
I only have to plug in one thing.
Plug in
I'll tell you what in a minute. But how do I figure out my y-axis scale? Don't I have to know stuff out here?
Yeah.
So let's plug in. What's a couple of good points to plug in? I have to know something about out here, so of course I'm going to plug in.
-6.
Or -5 will do, because -6 is not on mine,
Okay.
right? And then also we're going to plug in something up here, so I can just plug in
3.
3. Not sure what happened to my number 3.
Three's 25 over 21.
Say again?
25 over 21.
3 gives you 25 over,
21.
let's see, 21? Yeah, I'm with you. Which is roughly, which way, 0.5, so it's 0.05. I think it's roughly 1.05, is that right?
1.1904.
Oh, yeah, that was close. 1.19? What did I do wrong? Oh, I see, okay. Big cell. And then f of -5, does somebody have that one?
-9 over 35.
-9 over 35, yeah. Let's see.
9 over -34, like that.
Or 9 over -35. Or, I mean.
Doesn't matter.
It doesn't matter.
Yeah. Okay. The negative, normally we float it up to the top, right? Which is roughly, almost 936 would be 1/4. This is roughly -0.25,
Yes.
roughly. We're doing this by hand, so we don't have to be perfect. Okay, so it looks like my y-axis scale, I might, and what was my my horizontal axis was 0. So let me see if you guys are cool with this. Here's something you can do to be really nice to yourself. I'm going to make my y-axis scale go by a half. So I'm going to go 0.51, 1.52, 2.5. Why wouldn't I? Give myself some more room to breathe, right? Sort of like moving the test to Tuesday. Alright, so we know f of -5 is negative. Oh, I can plot my the horizontal asymptote was 0, Jeff. You could have plotted that already. F of -5 is -0.25. So can anyone fill in what it looks like down there? Can you guys see what it looks like down here? Could you draw that in? As I move this way, as I move in this direction, what must it be doing?
Approaching the.
Yeah, it's got to slam up against that wall. And as I go backwards, it must
Slam up against.
that wall. I love it. F of -3. I'm sorry. What did we do? Oh, we did F of 3. We haven't done F of -3 yet. F of 3 is 1.19, which is about right there. So again, I know it's got to come from that wall and then go to that wall. Now in the middle, I know it's going to turn here. And it's got to live in here. Does that make sense? I'm sorry. Oh yeah, we still have this other region. So I have 1, 2, 3, 4 regions. So what else do I need to plug in here? Let's see. What's happening in this region? Yeah, if I plug in a 1, I'll see what's going on there. In this region here. When I plug in a 1, I get, looks like 9 over 15. Yeah. You guys kind of with me? If I plug in a 1, it looks like I get 9 over 15. Negative 15?
Negative.
Negative 15, yeah.
Wait. No.
Yes. Oh, no.
No, you get 5.
9 over
5.
negative 5.
Yeah.
Okay. Which is almost 2. It's negative 1.8. So at 1, it's at negative 1.8. So I want you to see, does it make sense that it can't go up here? There's no x-intercept, correct? So it's basically going to look something like this. I don't know if this is the highest point, but I'm not supposed to know. I didn't have to do enough work for that. And then finally, if I just plug in a negative 3, I'm going to do this a little bit quickly. We're out of time, but you shouldn't do this quickly, Jeff. 1 over, let's see, I think it's 15. So it's down here. So therefore it's going to look like this, because it's got to turn it to. It's got to turn it to. That is exceptionally freaky. Alright, that's enough for now. So next time we'll talk about slant asymptotes, and then we'll get into chapter 6, exponentials. Okay.